Hi everyone, I'm going to share with you the latest innovation from Pensee in the field of seismic hazard analysis. And this innovation is very exciting in the sense that it will make everyone convenient to analyze the seismic risk in the Philippines. First, I need to click this button and I'd like you to pay attention to the crosshair here. If I click any location, for example, um, the satellite map of Google will appear, and this coordinate here is the side coordinate under the crosshair. So if I move the map here, the coordinate also changes because the location now under this crosshair is different from the previous one. Now say for example I'm going to analyze the seismic hazard in Cebu City. I'll click Cebu City and the satellite map of Google will appear, and then I will drag the map so that the crosshair is directly above the site I want to analyze. For example, I want to analyze the seismic hazard in Seaside City, and this is the coordinate of Seaside. Then I will choose the return period of earthquake, and then I will choose the number of simulations. The reason I am giving the user different options for the number of simulations is that I want the user to understand that earthquakes are random. Say for example, if I will use only one simulation run, click the run button here. These earthquake parameters of 5.7 with a hypocenter of 19 kilometers is the corresponding earthquake with a return period of 475 years. And now this is the simulated ground motion, and this is the response spectra. If you notice, the response spectra is very rough because earthquake motions are random. Now to overcome this problem, the user can run multiple simulations of the earthquake with this parameter. Say for example, if I will use 10 simulations and then run the analysis, you will notice that the response spectra is much smoother than before. And if I use more simulations, this time 50, the response spectra is now much smoother than the first time I did the single simulation run. What's very exciting in Pensee is that this response spectra can be exported in case you want this response spectra to be used by another software, or you want to analyze by yourself. Then you can save the data here, for example test 5, and I have just saved the data of this response spectra, and I can use it later or using another software. Now I have also the option of using actual ground motion data by clicking this button. I call this import because this will import other data. For example, this is the acceleration data of El Centro earthquake, which is very famous. See, this is the recorded ground motion during the El Centro earthquake, and this is the corresponding response spectra. And as you can see, it's very rough because this is only for one earthquake ground motion. Now let's go back to this site analysis here. I can run another return period, and then see, because the return period is much longer now, it's 2475. Thus the values of the response spectra is also much higher. Now you might be wondering why it's smoother to have more simulation than a single simulation, and the reason for that is Pensee will conduct a statistical analysis of the response spectra and get the average of all the simulations. Another cool feature of Pensee is that it can simulate earthquakes of any magnitude and hypocenter distance. What I have shown before were earthquakes based on seismic hazard analysis, and this time I'm going to show simulated earthquakes by designating the magnitude. You can see here I am changing the earthquake parameters, and then click the simulation button. Now you can see that Pensee is simulating earthquakes based on my designated earthquake parameters.